Hello everybody, welcome back to physics. This is our third discussion about circuitry. And my question was, did you guys find the current through number 4? Oh, number 4 resistor right here. Good, that's exactly right. Okay, we're going to have to go through that step by step. Okay, so we're going to start going through this here. And the first thing we want to do is, like where we left off yesterday, we figured out the overall resistance was 9.13 ohms. Okay, so, there's no questions about that. We all figured out how to do that much, right? And so the next thing that I would do then, and I'm going to label these I's. So I'm going to call this I1. I'll call this I2. I'll call this I3. And I don't know if I need any more. What would this one be? This is I1 again. Do you agree? Because Kirchhoff's rule one of his rules is that all the current that goes out of a battery goes back into a battery. Okay, so we have the total volt drop for the system is 12. And we have the total resistance. So the first thing I want to do is find the total current. So the current total then is volts total divided by resistance total, or 12 divided by 9.13. The current total is 1.314 amps. Okay, very good. Now, if I have that, then I know that is the total amount of current that's going to flow from here to here. Now, it just so happens that that current splits up, so part of it will go this way, part of it will go this way, and then that'll split up again, that'll come back together again, and then finally, at the end, it'll all come back together. But I can say that the total current that I just determined does flow through this whole part. And why that is beneficial to me is if I know the total current and I can figure out the total resistance of that part, I can find the volt drop of that part. So that's what I'm going to do this time. There's a lot of different ways to do this. So my volt drop then over the parallel part is going to be equal to the current through that, which is the current total in this case, and the resistance of the parallel part. Well, if I know that this resistor down here is 6, and this one is 1, that's 7, then I only have 2.13 ohms attributed to that whole entire parallel part. So 2.13 ohms is the resistance of that whole entire parallel part as a group. So my volt drop across my parallel part is those two totals. So 1.314 times 2.13. My volt drop across the parallel part then is 2.7988. And I do like 4 decimal points on this stuff. So good. That's how many volts I drop across that part. Now, could have I done that another way? Yeah, I could have figured out the volts that I drop out here, right? So the volt drop across the 1 is going to be equal to the current in number, which would be 1.314 volts, because it's a 1 ohm resistor. And then the volt drop across the 6 ohm resistor is going to be the current times that 6 ohm resistor, which that 1.314 times 6 is 7.884 volts. Okay, so this plus this, okay, is the total volt drop besides the parallel part, okay? So 7.884 plus 1.314 is 9.198. And since I know I only have 12 volts to drop total, whatever should be left over should be about 2.7988. Although the decimals are going to be off probably. But you should come up with the same answer both ways. 2.802. Okay. So you could do that part either way, right? Okay, so now that we have the volt drop across the parallel part, then we can figure out how much current is flowing through the 5 ohm resistor. Because the volt drop across the 5 ohm resistor is equal to 2.7988. Just like the volt drop across the left side of this parallel part is also equal to that. Okay, so if I wanted to, I didn't ask for that question, but we might as well. Okay, so the current through the 5 ohm resistor is 2.7988 divided by 5, or the current is 0.5598 amps. Now I didn't have to do that, but it turns out that that is actually beneficial to me.
Okay.
And the reason why is because, what? That's the total current that goes through this side. And we said that our total current for the whole thing is 1.314. So if I'm asking how much current goes through this side, then I can just say what, Sage? Yeah, it's very good. So this current right here is what travels through this resistor, and through this whole entire parallel part.
Should be money.
Okay, so in other words, due to the conservation of current, one of Kirchhoff's rules, whatever flows in to the parallel has to flow out of it. So in this case, part of it goes this way, part of it goes this way, and then that splits up. So if I figure out how much current is going this way, then I know how much is left to travel that way. Does that make sense? Yes, and Keely and Haley already did that, pronto. So what they did is they took this total current and they subtracted the amount that was flowing in this direction, and they figured out how much current was going the other way, girls. 0.7542 amps are flowing this way. Okay? So now I know that's how much current is flowing through this resistor right here, which is the 2 ohm resistor. So we said that this resistor underneath all this stuff is a 2 ohm resistor. If I figure out the volt drop across that 2 ohm resistor, then I have the volt drop across this part of the circuit, and with that I can finally figure out how much current is going through that resistor. I decided to erase some of this just to make it easier to read. We know that there's a total current that goes into this situation equal to 1.314. Do you agree? And we know that part of that current goes through here, and the other part goes through here, and then it splits up into 2 pieces here, and then comes back together until finally everything's back together here. We know that, right? We know by definition that the volt drop across this entire parallel part is equal so if we figure out the current that flows through this part, let's do that. It's 0.7542 amps. Any questions on how we got that? Or wait, I'm sorry, did I screw that up? I'm sorry, it's, yeah, thanks Kaylee, it's 0.5598 amps. Anyone have a question on how we did that? Because we figured that out, then we, by default, figured out that the amount of current going through this part is 0.7542 amps. Okay, so now we're going to use this current to figure out the volt drop that I lose right here at the 2 ohm resistor. Okay, so the volt drop across the 2 ohm resistor is according to the current across the 2 ohm resistor times the resistance of the 2 ohm resistor. In this case, it's 0.7542 times 2, or the volt drop is 1.584 volts, if I did the math correctly. 1.5084 volts. Okay, so the question is, which voltage is this? Well, this is the volt drop across the 2 ohm resistor here. Okay, so what does that do for us? Yep, say it. I know you're right. Okay, so what we do with that is we take this total volt drop of 2.7988 that goes across this whole entire piece, and we subtract the amount we lost there, which is 1.5084. 1.5084. And how many volts then are left to drop across this parallel part is the question. 1.29 what? 04. That's how many volts we have left to drop across the 3 and 4 ohm resistor. So now we know that the volt drop, I'm going to erase some of this stuff here. Okay, so we determined that the volt drop across the 3-4 part, so the volt drop across this is 1.2904 volts. So now we can find finally the current through the 4 ohm resistor. Current through the 4 ohm resistor is volts divided by the resistance is 1.2904 divided by 4, or 0.3226 amps. And there's our final answer. Hopefully that helps you understand these types of problems.